Okay, question 35. Write an equation for the graph of the trigonometric function shown below. Wow. For this question, you really need to know how the different curves of sine, cosine, tangent, and etc. looks like. This one over here looks like a sine curve, and the way I describe a sine curve, usually from 0 going forward, is usually looks like a roller coaster. Right, it goes up first, down below, and whoop, swings back up. Right, that's usually how sine looks like. Cosine starts on the very top and it comes down and looks sort of like a U, right? And this is, from the measure of 0 to pi. Well, this curve over here looks very similar to the sine curve. It's just that it is flipped over or reflected over the x-axis. So that's this curve is actually y equals negative sine, to represent that has been reflected over the x-axis. Okay, let's see what other information we can get from this. Well, the amplitude is the middle, right? Middle of the graph, or the line that cuts the graph in half, to the bottom or to the top, right? Let's see how many units, or how high or how low that's going to be. That seems to be 3, right? Right, or negative 3. So the amplitude is always the absolute value or the positive value of that height, that measurement. It's 3. So that goes in the front. So it's negative 3 sine. Let's see what else we can do over here. We also need to find the frequency, right? So the graph is, usually in the form of y equals a, sine bx, right? We got a, that's the amplitude. B is the frequency. Frequency is the number of cycles, right? Complete cycles you see from 0 to 2 pi. So from here, we see that it starts at 0. This full cycle ends at pi. So if I want to find out how many cycles it ends at 2 pi, well, we're going to have to stretch this a little bit out, right? Let's say 2 pi is towards the end over here, right? If you continue this pattern, right, how many cycles will we see at 2 pi? So let's continue going down, right? It's going to swoop back up again, and it's going to come back down, right? If it completes 1 cycle at pi, at 2 pi, it should complete 2 cycles, right? So that is a frequency of 2. So that is 2, okay? And that is your answer. Okay? There you go. Okay, let's take a look at the next one over here. Expressed in simplest form. Wow, there's a lot of long polynomials and binomials here, and usually when these questions comes up, you probably need to factor. So let's take this. We got this fraction divided by the bottom. So let's rewrite this. Let's just factor the top first. Okay, 4 minus x squared. Well, that's 4 minus x squared is the same as 2 plus x times 2 minus x, right? Difference of 2 perfect squared divided by x squared plus 7x plus 12. So this, we can factor it out as x plus 4 and x plus 3. And now it's getting divided by that, right? So it's getting divided, right, by 2x minus 4 over x plus 3. But whenever we divide by another fraction, we can always flip it, right, and change into multiplication. So let's do that first. Okay. So now we have x plus 3 on the top and 2x minus 4 on top. On the bottom. And 2x minus 4, we can factor this. Right, we can factor this to 2 times x minus 2. And now it seems that everything's fully factored. We can start crossing out or cancel. And this is my favorite part. I just look for things that look exactly the same. Oh, x plus 3, I can cross it out. Let's see what else I can cross out. Well, we'll get x minus 2 here, and that's very similar to something on top, but not totally there, right? X plus x minus 2 and 2 minus x. Well, they're exact opposites or inverses of each other, right? That's positive x, that's negative x, that's negative 2, that's positive 2. So you can actually cancel them out, but with these two, because they're exact opposites, you need to leave a negative 1 behind, okay? So I'm going to multiply what's left, so it's negative 1 times 2 minus x, 2 plus x, so it's negative 2 minus x over x plus 4. Ooh, and times a 2 over here. So let's just put times 2, and then we have negative 2 minus x over 2x plus 8, right? And we can leave that as your answer. You can write it with the x first. That'll be negative x minus 2 over 2x plus 8, right? Right, or if you want to get fancy and you want to factor some more out, you can have negative x plus 2 and leave this as 2x plus 4. Right, all these should be valid answers. Any one of these will be sufficient. Alright, let's move on to the next question over here. Okay, question 37. During a particular month, a local company surveyed all its employees, determined their travel time to work in minutes. The data for all 15 employees are shown below. Determine the number of employees whose travel time is within 1 standard deviation of the mean. Right? So another statistics question over here. So with this question, you're going to take out your graphing calculator again, and you're going to input all these numbers here, all this data into the calculator. So I'll take out mine. You can reach for yours. Alright, I'll turn mine on. I'm going to clear it. We're going to go into stat again because it's a statistics question, and click enter. And as you can see, all my data from the last one is still there. So I'm going to clear this. Press clear down. Then I'm going to clear this. Alright, press clear down. All my data information from the question before has been deleted, and now I'm going to enter all this new information. Alright, so 25, 55, 40, 65, 29, 45, 9, 35, 25, 37, 52, 38, 40, and 55. Okay, now that entered all the information in, I'm going to click on stat, statistics. I'm going to go over to the right to calculate, and for standard deviation, we're going to use number 1 over here. 1 variable stats or statistics. Okay, press enter over there, and you want to tell the calculator where to input the information. So I'm going to press second 1, the L1. All my information is L1, right? So I'm going to press enter over here, and it gives you a few information. The first one is mean. The average is 40. So between all the 15 employees, their average travel time is 40 minutes. And the standard deviation is this symbol over here is sigma, and that's 14.9. Right, 14.9. So I'm gonna just I'm gonna write that information over here on this paper. So the average time, right? And get this pen working. Okay. All right, come on. Okay, the pen is finally cooperating. Alright, so the average is 40, right? And let's take a look at the standard deviation again. I believe it is 14.9. 14.9. And well, how standard deviation looks like is, it's based on normal distribution. It looks like a bell curve, something like that, right? The average is 40. right? One standard deviation away, right? Is this over here? All right, on the left and the right. What this means is to get uh, the number for one standard deviation away, you need to take 40 and subtract 14.9. That is going to be 25.1. That's one standard deviation on the left of the average. And for the right side, you can take 40 plus 14.9, and that'll give you the standard, the range on the right side over here, which is 54.9. And the question, since it's asking for the travel time within one standard deviation of the mean, the travel time is anywhere from 25.1 minutes, right, to 54.9 minutes, right? Right, and just to go even further, if they're to ask you, well, what percentage of employees travel within one standard deviation, with that you'll need to look at your reference sheet, and that is approximately 68%, right? If they're asking that question. I think within two standard deviation, something around 95%, and then within three standard deviation, that will be around 99.7%, right? Something very close to that, if they were to ask you the percentage, right? But this question didn't ask for that. It just asked you what is the travel time, and this is the answer over here. Question 38. Almost finished. Almost there. Two more to go. All right, hopefully I have enough time to knock it out in this video. The measure of the angles between the resultant and two applied forces are 60 degrees and 45 degrees. Right, so and the magnitude of the resultant is 27 pounds. Right, so we have the resultant, this is 27 pounds. And the angle it forms, so one side is like 60 degrees, and the other side is 45. Right. And what this forms is another parallelogram. Ooh, this is a horrible drawing. Let me try to do this one more time. Okay. We have a resultant of 27, 60 degrees over here, and 45 degrees over here. Okay, still not a good job. Okay, hey, I'm not the best artist over here, but let's try to work with it. Okay. Third time's the charm. Okay, here we go. So, and we want to find to the nearest pound the magnitude of each applied force. So we want to find, let's say you're standing over here, right? Right, and then, they're pulling you away. The force in between is 27 pounds, right? And this is force 1 pulling you, and this is another force 2 pulling you. So let's, let's find out what F1 and F2 is. All right. So, let's see. How do we solve this? Well, if we know this is 45 degrees, we should know that this is also 45. All right. Alter interior angles, I believe, from geometry. If this is 60, this should be 60. And 45 plus 60 is 105. So this angle must be 75 degrees. Now, to find F1, we can use the law of sines over here. We have one angle, 75 degrees, the opposite of 27, and 60 degrees is the opposite of F1. So we're going to set law of sines, sine 75 degrees over 27 equals sine 60 degrees over F1, force 1. Let's cross multiply. Okay, so we have 27 sine 60 degrees equals F1 sine 75. Now we're going to divide by sine 75 to move it over here. Sine 75. Right. Take out our graphing calculator, and we should be able to solve this. Okay, make sure my mode is in degrees, because that's what we need to solve in this one. Click on 27, sine 60 degrees. Right. And this is divided by sine 75. Okay, it's 24.2, but the question asks you round it to your nearest pound, so it'll be 25 pounds, right? So force 1 equals 24 pounds. Okay, so that's 1. Now let's find F2. So same scenario here, we need to find F2. We know that this angle must be also 75 degrees, opposite of the other one in the parallelogram, right? So we're going to set the same thing, sine 75 over 27 equals sine 45 over F2, right? Because 45 is opposite of F2. I'm going to cross multiply. So we got F2 sine 75 equals 27 sine 45, okay? We do the same, divide by sine 75, sine 75, and hopefully we have the answer for F2. Force 2 is 27. 27 sine 45 divided by sine 75. Oh, forgot to close this parentheses, that's important. So click insert, just put that parentheses there, right? Close this parentheses, and now let's press enter. 19.7, round to the nearest pound is 20. So force 2 is 20 pounds. And there you go. Those are the answer. Force 1, 24, and force 2 is 20. Let's move on to the last question. Okay, solve algebraically for all values of x. Alright. Save the best one for last. Okay, so let's set these both sides, 81 and 27, to have the same base. Another way of writing 81 is 3 to the 4th power, right? And 27, you could write it as 3 to the 3rd power, okay? And if you have trouble finding this, just do a factor tree, prime factorization of 27. For example, that's 9 times 3, 9 is 3 times 3, 3, well that's 3 times itself 3 times, so it's 3 to the 3rd power. Okay. Everything else, let's keep it the same for now. So this is x cubed plus 2x squared. This is 5x divided by 3. Okay. We need some room here. Let's see. Alright, clear some space for this one. Okay, so now that the base is the same, right? Now the base is the same. Well, let's simplify the exponent first. We got 3 to the 4th power, and it's raised to another x cubed plus 2x squared. So what happens when you have exponent raised to another exponent? You have to multiply these two, right? So it's 4x cubed now, right? Plus, right? 4 times 2, that's 8x squared, right? Equals the other side, that's 3 times 5x over 3. Well, that's 3 to the 15x over 3. Okay, and 15x over 3 is the same as 5x. Okay, 15 divided by 3, 5x. Now, once the base is the same, all right, base is 3 and 3. We really don't need the base anymore to solve for x, right? Because we can actually cancel these out or take them out of the picture. We don't need to use anymore. You can set the exponents equal to each other. Okay, so we got 4x cubed plus 8x squared equals 5x. Right, we can move the 5x to the left side by subtracting 5x. We're left with 4x cubed plus 8x squared minus 5x equals 0. Let's see what they have in common that we can factor out. Aha, they all have an x. Let's factor x out. So we got 4x squared plus 8x minus 5 equals 0. Okay, so from here, you do need to factor 4x squared plus 8x minus 5. It gets a little tricky because the coefficient in front of x squared is a number that's greater than 1. Right? Anytime it's greater than 1, it's a little tricky. Right? 4x squared. But the factors are going to be 2x minus 1 times 2x plus 5, right, equal to 0. Now to get the solution, solve for x, you set each factor equal to 0. So it's 2x minus 1 equals 0, and 2x plus 5 equals 0. So this is one answer, x equals 0. Move the 1 over, divide by 2, and you get x equals 1/2. That's another factor, another answer, I'm sorry. Now you can move the 5 over and divide by 2. You get x equals negative 5 over 2. Right? And these are the three solutions for x to make the equation equal, or to make it work. So thanks a lot for watching all these videos. It probably took you a lot of time to go do this, but hopefully this helped you a little bit in the regions that's coming up. If you have any comments, please comment below. If you like the video, click on like. If you want to see more updates, click on the subscribe button, and hopefully I'll release more videos this week to give you a few more questions to help you out in the regions or in the future. Good luck on the tests. Best of luck. Take care. Goodbye.